I am K. Shahul Hamid, Professor ECE, Sedu Institute of Technology. In this session, we are going to discuss a problem which is related to polar plot and which will come under linear control engineering. So first I will read the problem statement. The open loop transfer function of a unity feedback system is given by g of s is equal to 1 plus s into 1 plus s into 1 plus 2s. Sketch the polar plot and determine gain margin and phase margin. So they have given a system function and we need to plot polar graph. Using polar graph we have to find out phase margin and gain margin. So first step in plotting polar graph is we have to substitute s is equal to j omega in the open loop transfer function. So when you are substituting, we get g of j omega is equal to 1 divided by j omega, 1 plus j omega, 1 plus 2 j omega. Now we need to find out corner frequencies. When you are seeing the transfer function, we have two corner frequency. One is here, one is related to this one, and another one is related to this one. So first corner frequency, that is omega c1 is equal to 1 by 2. 2 is the coefficient of j omega. So this one. So 1 by 2 is equal to 0.5 radians per second, and omega c2, the second corner frequency, is 1 radian per second. 1 is related to the coefficient of j omega, this polynomial. Now we have to write each and every term in terms of magnitude and phase. So 1 divided by first j omega, this is written like magnitude of j omega and angle of j omega. Second term is this one, and this is written as magnitude of 1 plus j omega and phase angle of 1 plus j omega. The third term is magnitude of 1 plus j2 omega and phase angle of 1 plus j omega. Now we have to take magnitude and also phase. So magnitude of j omega is omega, and magnitude of phase angle of j omega is phase 90 degree, and magnitude of 1 plus j omega is square root of 1 plus omega square, and phase angle of this one is tan inverse of omega. That is, omega is nothing but imaginary part, and here real part is 1. And regarding 1 plus j2 omega, the magnitude is square root of 1 plus 4 omega square, and the phase angle is tan inverse of 4 omega. Now I am going to simply separate magnitude as well as phase. So when I am separating, I get 1 divided by omega square root of, because square root is common, so square root of 1 plus omega square into 1 plus 4 omega square, and when you are comparing phase angle, we have to add it, and here it is in all phase angles or in denominator. When it comes to numerator, plus will become minus. So phase angle is minus 90 degree minus tan inverse of omega minus tan inverse of 4 omega. Now I am simply multiplying 1 plus omega square and 1 plus 4 omega square, and I get result like 1 divided by omega square root of 1 plus 5 omega square plus 4 omega power 4, and the phase angle, this is the magnitude, and this one phase angle of g of j omega is minus 90 degree minus tan inverse of omega minus tan inverse of 2 omega. Now we have to find magnitude as well as phase angle for different set of frequencies. Here important note is we have two corner frequencies. One is 0.5 radians per second and another one is 1 radian per second. So we have to choose a range of frequencies in which these two frequencies, that is two corner frequencies, should be included. So I am just starting with the 0.35 radians per second for this phase angle. For this frequency, we have to find out magnitude. The magnitude is 2.2 and the phase angle is minus 144. Then I am choosing 0.4. For that it is 1.8 minus 150, 0.45, 1.5 minus 156, and then 0.5, 0.6, 0.7 and 1. So for these frequencies we have to find out magnitude as well as phase angle. Once we obtain this, we have to mark the points in the polar graph and connect the points. So this is polar graph. This is polar graph. You can see circles and also lines. So circle represents magnitude. So circle represents magnitude, and the lines represent phase angle. For example, we are taking starting with 0, right hand side 0, and you can consider clockwise and also anti-clockwise. When you are considering clockwise, the degrees you have to choose like -10, -20, -30, -40, and it's go like that, negative degree. When you are considering anti-clockwise, it is positive 10, 20, 30, and you can see both. 10 degree means is equivalent to -350, and here -10 is equivalent to 350 degrees, something like that. And when you are seeing left hand side 180 degree minus 180 degree represents the same point. Now we have to mark all these points in the polar graph. So that is, we have to mark phase angle versus magnitude. So just see this table, and we have to choose a point with respect to phase angle and magnitude. First we are going to choose 2.2. Before choosing these points, we have to mark the scales in the polar graph. As far as phase angle concerned, already it's marked. So 0 to 360 degrees is marked, and we have to specify magnitude. So we are considering one circle. In this one circle represent 0.05 magnitude. Okay, so if you are taking this graph, the center point is 0, and the first dark line is 0.5, second dark line is 1, that is unit circle, and third dark line is 1.5, fourth one is 2, and fifth one is 2.2. So each and every circle represents 0.05 unit. Now first point is 2.2. For this 2.2, the phase angle is -144. 144, so we have to take clockwise. Clockwise in the sense all are negative, negative degrees are in negative. So 144 comes after 1 minus 140. So this is -140, and this is -150, and 144 is in center almost center. So this is, you can say this is 144, and the magnitude is around 2.2. 2.2 should be after 2 this point. So first point is 2.05, this is 2.1, 2.15, and this one is 2.2. so this line and this line, so this is the point, this represent 2.2, and the phase angle is -144. The next one is 1.8 minus 150. So we know 150 minus 150, and 1.8 is after 2. So 2, the next point is 1.95, and at almost something like that. We have to so each and every circle is 0.05. When we are calculating, this is 1.5, and this point will be 1.75 because center, and the next point is 1.8. so almost here, just take this, and 1 minus 150, 1.8. the second point. Third point is 1.5 and minus 156. 1.5 is this circle, and 156 will be in between 1 minus 150 and minus 160, and almost a center point. This is the point which represents 1.5 and minus 156. The next point is 1.2 and minus 162. 162 is above minus 160, and somewhere here, and the point magnitude is 1.2. 1.2 is after 1 this is 1.05, this is 1.1, 1.15, this is 1.2. so this line and 160 to this point. Similarly we have to mark all the points, and the last one is 0.3 minus 198. Minus 198 is above 1 minus 190, and it's very close to minus 200, so it's somewhere here, this point the magnitude is 0.3. 0.3 is 0, it's below 0.5, so this is 0. This point. So now we have to connect all the points using free hand. So when you are connecting, and you have to connect with the origin. So this is related to polar plot. So we have plotted the graph. Now we have to find out gain margin and phase margin. So for a gain margin is represented as g of that is k suffix g, which is equal to reciprocal of gain at phase crossover frequency. Phase crossover frequency is nothing but minus plus or minus 180 degree. This one is phase crossover frequency, and we have to find the point point at which the locus cut phase crossover frequency, that is minus 180 degree. So here for this case, the locus is cutting 180 degree line at 0.7 magnitude. So when you are substituting this in this equation, we get 1 divided by 0.7, which is equal to 1.426. so this is the gain margin, and phase margin gamma is equal to 180 degree plus pi gc. Pi gc is nothing but phase angle at gain crossover frequency. Gain crossover frequency is nothing but the point at which the locus cut unit circle, and this is the unit circle, and this is this unit circle, the locus cut this unit circle, this point, and we have to connect this point and the center point. So when you are connecting and extending this, it will give an angle. That angle is pi gc. So this is pi gc. So phase angle at gain crossover frequency, and this angle is minus 168. Now we have to substitute this in this equation. We get 180 degree minus 168 is equal to 12 degree. So these are the actual definition of phase margin and gain margin. So I just read the definition. Gain margin is defined as inverse of magnitude of g of j omega at phase crossover frequency, and phase crossover frequency is the frequency at which the phase of g of j omega is 180 degree. Phase margin is defined as gamma is equal to 180 degree plus pi gc, where pi gc is the phase angle of g of j omega at gain crossover frequency. So the gain crossover frequency is the frequency at which the magnitude of g of j omega is unity or 0 dB. So we have started the problem with transfer function, open loop transfer function, and we have substituted s is equal to j omega, and then we have separated magnitude and phase angle of each and every term, and we came with magnitude as well as phase, and then we have determined phase angle as well as magnitude for different set of frequency, and then we have marked all these points in the polar graph. After marking the polar graph, the locus cut in two different places, like unit circle and also 180 degree. Unit circle, it is actually called gain crossover frequency, and the 180 degree line, which is called gain crossover phase crossover frequency magnitude. Based on that, we have determined gain margin and phase margin, and this is the result. 1.4286 is the gain margin, and 12 degree is the phase margin. So with this I am closing this session. Thank you very much.